Hey guys, Zulk here, back on my bullshit. So, I wanted to record another learning C++ video for the past 2-3 days now, but I kinda got sick. I'm still not feeling great today, but I am feeling a lot better than I have the past 2 days. So, there is that. Anyway, before I started recording, I got mesmerized by this thing. I don't know why. But I was just staring at this for way longer than I'd like to admit. But yeah. Anyway, let's get back on this C++ learning grind. And as always, I need to get this disclaimer out of the way. If you clicked on this video thinking this is a tutorial and that I'm going to teach you how to program in C++ in any quick and efficient manner, this video series is not for you. This series is less a tutorial where someone who knows what they're talking about teaches you how to do certain things in C++. This is not that. Instead, this is someone who has coding experience in other programming languages trying to use a book to teach themselves the ins and outs of C++. So this is more like a learning diary for myself. You might be able to learn how to code in C++ by watching this series, but it's not going to happen in any efficient or timely manner. So if you need to learn C++, or if you need C++ to do something, I recommend you click off this video right now and go find a better tutorial on YouTube somewhere. I'm sure you'll find many. And one last thing, whatever it is you need C++ for, good luck with that. I hope that goes well for you. So anyway, with the disclaimer out of the way, and whoever is left here, let's continue with this thing. When I first started this series, I considered it like a let's play, but instead of a game, I'm trying to learn a skill, which is C++. And I essentially pulled a I forgot to save moment before I started recording. Every video when I'm done learning C++ for the day, I usually use a pen that I have right next to me on a table to mark the last part in the book where I studied up to, so I can continue out from there in the next video. And I forgot to do that, so I had to read through 2 pages, well, not read, skim through 2 pages to figure out where I was. But I think this is where I left off. Introducing inheritance. Again, I am not going to read the whole book word for word, line by line. I am just going to read those parts aloud which seem interesting to me. Inheritance is the mechanism by which one class can inherit the properties of another. Yeah, I know what inheritance is. I think I did some inheritance stuff in Python when I did that one project when I made a video game in Python using Pygame. So I believe I did inheritance where I had this super class that was the enemy class, and then there were like two different enemies. No, there was like one enemy that inherited from the superclass. Inheritance allows a hierarchy of classes to be built, moving from the most general to the most specific. When one class is inherited by another, the class that is inherited is called the base class. The inherited class is called the derived class. The process of inheritance begins with the definition of a base class. The base class defines all qualities that will be common to any derived classes. A derived class inherits those general traits i.e. the general, uh, I guess, properties or functions or whatever that's in the base class, inherits those general traits and adds properties that are specific to that class. To understand how one class can inherit another, let's first begin with an example that, although simple, illustrates many key features of inheritance. To start, here's the declaration for the base class. Let's actually erase all of this and do this example. Hold on, I need to, yeah, class B. I get nervous sometimes. Like, I know what I'm doing, but I still end up getting really nervous sometimes about all of wrong. That's the wrong brackets. Why am I? Oh, that's why I was accidentally pressing down on caps lock instead of shift like I was supposed to. So this is class B, which is void. It will it will return a void. So we have private an integer I, and we have the public stuff, which is a void function set I, which will take an integer n. I forgot, how do I define a function again? Like this, right? This is how you define a function. I really need to be more confident in this stuff. Like, I know what I'm doing here. Like, deep down, I feel like I know what I'm doing. But at the same time, I'm like, but what if I'm wrong though? Is that common? Is that normal? I don't know. I made a mistake here. I just realized I this thing is not for classes. That's for this shit. Functions. I don't have to do class void or whatever. That's not how you do shit. Ever. No, I'm pretty sure you don't do that in. Hang on, do you even have classes in C? I I can't remember if you have classes in C or not. Like, I know you have them in C++. I'm writing a class right here. But do you have it in C? Yeah, fuck it. I think I'm doing good enough. Now, where it was then? So, we have set n. We have set I. So, here I'm going to set I equals to n. I think that's the function here. That's the play. And then we have get I, a different function. int get underscore I. It takes no uh, it takes no arguments, so void, and then I guess it just return I. And this is my class. Then what? Oh, no, there's more text. Let me read it real quick. Okay, let's continue on. I really need to get more comfortable with this. Oh, I don't need to say B public class. I just need to say public B. And here we have a private integer that is J. And we have the public functions. I should put a space just for readability's sake. Where we have void set underscore J. And it will take an integer n. I'm going to define this class right here, right now. Set J is J equals to n, just like with set I. And then we have integer mult. Well, mul. And this takes no parameters, so void, I guess. Hold on, can I check something real quick? Yeah. This takes no parameters. I want to check a few things. I need to go back to this section. Yeah. Now where was I? Oh yeah, mul. Return the value of basis I times derives J. Oh, okay. So that means I just do this. Wait, I pressed on the wrong thing. This one should be return J times get I. Where I'm calling a function The reason I'm doing this instead of putting directly I, because I is at the end of the day a private integer part of class B, part of the private class B, and even though class D inherits from B, it does not inherit the private parts of B. When I said private parts of B, it sounded kind of wrong, but yeah, it does not inherit the stuff in the private section, just as the ones in the public section, but it can still access it via this get I function. All right, so that should be the class D. Now let's write some code to see if this works or not. First, of course, I need to create an object of the class D, and I'm just going to follow the book here. I was thinking of using a cheeky name for this, but I'm just going to follow the book. ob.set I. It should have set I function because D inherits from B and set I is a public function in B. Let's do something simple. 2. So the value of I is 2 now. And then op set J, and the value of J I will say is 5. So I should get 10. Let's do 3 and 5. Get 15 instead. Why not? And now output cout ob.mul. Return 0 because I put it as an int main and not a void main. Okay, if this works, I should get 15 as my output. Hey, there we go. It worked. I got 15 as my output. Nice. Let's try something. Let's just really stress test this for a bit. I'm going to define a different thing. Class B, OB2, OB1 and OB2. I am going to have to change these things. OB1. And now this is OB1 mul. Got it. Let's try something else now. We know this works. Let's see. OB2 dot set I equals to 2. Yeah, let's do this. Cout hold on, \n gives me space, right? I kind of forgot that. Cout, then cout again. First, let's do this. ob1 dot get I underscore I. I'm calling the function. Then \n, then does \n have to be within this? Possibly. Then ob2 dot get underscore I. There's another thing I want to do first. Another over here, ob1 underscore ob1 dot mul, not underscore, ob2 get I. There. Let's see if this works. Oh right, I keep forgetting the semicolon. So we have 15 because of this. All right, no space. So then we have get I, which is tree. Yeah, for ob1 it's get I, and ob2 is 2. Yeah, there should be a space here, which is why it says 315, but it's actually not saying 315. It's just me being a dumbass with my output statement. What it's actually saying is 315. So this is right. It would be more right if I put a space somewhere, but whatever. So we know it works. We know how it's working. Here we have ob2, which is an object of the main base class, and ob1, which is an object of the inherited class, and they are working completely separately, not interacting with each other. Neat. So let's keep moving forward. Object pointers is the next section. So far you have been accessing members of an object by using the dot operator. Yeah, see this dot thing right here. This is the correct method when you are working with an object. However, it is also possible to access a member of an object via pointer to that object. When a pointer is used, the arrow operator rather than the dot operator is employed. This is exactly the same way the arrow operator is used when given a pointer to a structure. You declare an object pointer just like you declare a pointer to any other type of variable. Specify its class name and then precede the variable name with an asterisk. To obtain the address of an object, precede the object with the AND operator, just as you do when taking the address of any other type of variable. Just like pointers to other types, an object pointer, when incremented, will point to the next object of its type. And we have some examples here. I'm just going to read it. So yeah, the pointers seem to work, well, logically speaking, pretty much exactly like how they work in C. So I think I'm good here. And this line might come up later. We will come back to the subject of object pointers in chapter 4 once you know more about C++. There are several structural, there are several special features that relate to them. Yeah, there's a bunch of stuff you can do with pointers. I always found it kind of complicated if I'm being perfectly honest with you. Uh, I always found pointers complicated to work with. I actually, now that I'm saying it, I think complicated is not the right word here. More intimidating. I've always found pointers intimidating to work with. Even though I have done things using pointers when I was coding in C. I think I also did stuff with pointers, well, using Python as well, but very rarely. Because again, I found working with pointers intimidating, so I would avoid them whenever possible. But sometimes I did have to resort to using them. I just didn't like doing it. I don't know why. Is this just a me problem? Am I the only one who finds pointers intimidating? I don't know. The next topic is classes, structures, and unions are related. I don't know what a union is. The class and the structure have virtually identical capabilities. In C++, the definition of a structure has been expanded so that it can also include member functions, including constructor and destructor functions, in just the same way that a class can. In fact, the only difference between a structure and a class is that by default, the members of a class are private, but the members of a structure are public. The expanded syntax of a structure is shown here. Okay, I did not know this. Structured name, public function, and data members. According to the formal C++ syntax, both struct and class create new class types. Yeah, I'm wondering this as well. On the surface, there is a seeming redundancy in the fact that structures and classes have virtually identical capabilities. Many newcomers to C++ wonder why this apparent duplication exists. In fact, it is not uncommon to hear the suggestion that the class keyword is unnecessary. The answer to this line of reasoning has both a strong and weak form. What? The strong reason concerns maintaining upward compatibility from C in C++. In a C-style structure, a C-style structure is also perfectly acceptable in a C++ program, since in C, all structure members are public by default. This convention is also maintained. Further, because class is a because class is a syntactically, that is a tough word to pronounce. Syntax to syntactically. Further, because class is a syntactically separate entity from struct, the definition of a class is free to evolve in a way that will not be compatible with a C-like structure definition. Since the two are separated, the direction of the future direction of C++ is not restricted by compatibility concerns. The weak reason for having two similar constructs is that there is no disadvantage to expanding the definition of a structure in C++ to include member functions. Although structures have the same capabilities as classes, most programmers restrict their use of structures to adhere to their C-like form and do not use them to include function members. Most programmers use the class keyword when defining objects that contain both data and code. However, this is a stylistic matter and is subject to your own preference. After this section, this book reserves the use of struct for objects that have no function members. Okay. If you find the connection between classes and structures interesting, so will you find the next revelation about C++ unions and classes are also related. In C++, a union defines a class type that can contain both functions and data as members. A union is like a structure in that by default all members are public until private specifier is used. In a union, however, all data members share the same memory location. Unions can contain constructors and destructor functions. Fortunately, C unions are upwardly compatible with C++ unions. I don't think I've ever used unions in C. That may have been a failing in my own way of learning C, but I don't think I've ever used unions before. I've used structures. I remember distinctly one time I made like a very basic um, text-based adventure game, kind of like a visual novel but without the visuals in C, where you solve puzzles and do things and type stuff, have like talk and interact and etc. Well, it's not like that. It's more like the the console prints out a bunch of options. What do you do next? Check this, do that, do this, and then when you press a key to select an option, it the game says what happens afterward, like a very railroaded choose your own adventure type of thing. I did that in C once, and over there I think I used structs to store a bunch of data about the player. I think that's what I did. I don't remember specifics. Give me a break. It's been like 4 years since I did that. So I don't remember the specifics of the code of how I did that. But I do know I did that. And I do know I used struct for some stuff. Hang on, what's this? Although structures and classes seem on the surface to be redundant, this is not the case with unions. In an object-oriented language, it is important to preserve encapsulation. Thus, the union's ability to link code and data allows you to create class types in which all data uses a shared location. This is something that you cannot do using a class. There are several restrictions that apply to unions as they relate to C++. First, they cannot inherit any other class, and they cannot be used as a base class for any other type. Unions must not have any static members. They also must not contain any object that has a constructor or destructor. The union itself can have a constructor and destructor, though. Okay, so they cannot contain any object that has a constructor or destructor. Unions itself can have a constructor or destructor though. So unions themselves can have it, but they just can't have an object inside it that uses one. Okay. Finally, unions cannot have a virtual member, cannot have virtual member functions. Virtual member functions are described later in this book. There is a special type of union in C++ called an anonymous union. An anonymous union does not have a type name and no variables can be declared for this sort of union. Instead, an anonymous union tells the compiler that its members will share the same memory location. However, in all other respects, the members act and are treated like normal variables. That is, the members are accessed directly without the dot operator syntax. For example, this fragment, blah blah blah, an example. Okay, the union part was kind of a lot to wrap my head around. I will say this though, an interesting thing. How long have I been recording? Only 35 minutes. I can go for a bit longer, I guess. One interesting difference I have noticed in class and structs in C++ though. So look over here. In every time I have been defining a class in this series, I've had a private section and I've had a public section, but you don't actually need that. In the examples of the book, the private section is just not there. It's like it's structured like this. See? So the private part is just as assumed. It's by default. But according to this book, it seems if I write something like this in a struct, then instead of this being taken as private, it will be taken as public. So in a way, I guess you could say that by default, the members of a class are private, but the members of a structure are public by default. I'm still going to clearly designate what is private and what is public whenever I make a class, because I just think that makes it easier for me personally to keep track of while I'm coding. Again, readability's sake. I really should get into the habit of leaving more comments in my code though, because otherwise I'm gonna have a heck of a headache trying to read my shit. But anyway, my brain feels like it is overheating. Well, I do plan on continuing this episode for a bit longer. I think I need to take a break. So I am just gonna pause the recording and I'm gonna go, I don't know, take a trip to the toilet, drink some water. Not in the toilet, I'm not gonna drink toilet water, don't worry. So, yeah, I'm just gonna take a short break. Maybe I'll watch a YouTube video or something, I don't know. Okay, so I know I said I was going to continue the lesson today, but I started feeling a lot worse after my break. I walked around a bit, I took a drink of water, I went to the toilet, and I'm feeling a lot worse now than when I started recording. So I think I should end the video earlier today. But of course, before I end, here is the obligatory chess video. Well, obligatory chess section of the video. Let's try and get my elo up back to 800 because I'm stuck at 794 now, and I tend to play a lot better when I am recording because I talk myself through various steps. Anyway, I want to put my pawn here, but the knight is defending it, so I am going to defend this square first. God damn you. I hate it when they do that. Now I can't even do this. So I guess I'm going this way. I'm gonna bring my bishop out and then put my pawn here instead. I would prefer to put both my pawns in the center because I'm bad at chess, and having two pawns in the center makes me feel more confident. But it is what it is. It is what it is. We have a semi-identical setup now. Let me put my knight here actually. Oh, no, you want to put your bishop here. So I can defend this, or, I'm just going to put my knight here. If you check me with a bishop move like this, I'm just going to move my pawn up. You guarded this square. Okay, I see you. I see you. Well, anyway, I don't know what to do next. I'm kind of stuck here. I guess I can clear the way for King Castle. Castle in King side. Or I can just push the spawn. No, I think I want to attack this knight somehow. I'm gonna push this pawn, finish this pyramid. Then I'm gonna put my bishop up here, and if takes, then I can put my queen up there. Somehow I forgot you could do that. I guess I should have seen that coming. I really should have. Anyway, I can put it here, but then this is going to be taken, and then this takes, and I'm gonna just be down a knight. So instead, I'm just gonna bring my knight back. I'm gonna pivot it. Okay. Queen attack. I can just move my queen out, right? Like, I can just move my queen here, so I can target this. I guess you can castle to protect it. Or that, or you can do that. And yeah, this might be a problem later. I can't move this. Oh my god. I am getting cooked, guys. I need to figure out some way out of this. I don't know how I got into this mess. Let me castle real quick. Then I'll push this pawn. I would have preferred to castle king side. I can just take this, right? Hold on. Takes. Oh. That is an attack from multiple angles. I can take with a pawn though. I was down for a queen trade. But now I can go back and attack your bishop, while also providing some defense to the knight here. Now I know bishop takes is possible, but then I'll just go back and take with the queen, and then attack this pawn at the same time, this weak pawn. So far we are equal in material, but I think my king's safety is worse. You are gonna fork my rook. I need to protect that square. And I know just the way to do it. Now you may be thinking, Zulk, he can just take. I'll take with this pawn, and that will just activate my rook. Give my rook an opening to move around all over the place. To rook around. Just as planned. Oh. I see what you're trying to do here. You're gonna move the bishop here, and my queen is gonna be fucking under attack. Huh. Can I do anything here? Well, I guess I can move my knight here, but then and this takes and my queen is still under attack. I have to move my queen. I just have to move my queen here. I guess I can do this, takes, then move queen here. No, then move queen here. I think I like that idea. So takes, then takes. And if queen takes, oh, what did I just lose? I lost my knight. I forgot that the knight was there. Wait, I can still move it though. Never mind, I just lost my queen. And I lost my rook too because I can't take. That was a disaster. I am just gonna get checkmated at this rate. Yeah, I don't think I can prevent checkmate here. Yep. Figured. Well, you can't win him all, I guess. But yeah, that's a good way to end this terrible episode. So guys, that's it for this video. If you like this video, be sure to leave a like, comment and or subscribe. Dislike it if you hated it. I'll heart your comment to let you know I've read them. So just because I hated your comment doesn't mean I agree with it or endorse it. I'm Zulk, and I'll be back with more bullshit next time. Goodbye.